Hello and welcome to this video that goes through this past paper question for momentum. Trolley T1 of mass 2 kilograms collides on a horizontal surface with trolley T2, which is also of mass 2 kilograms. The collision is elastic. Before the collision, T1 was moving at 4 meters per second and T2 was at rest. Which of the following statements is correct? So for this question here, we need to so there is obviously quicker ways to solve it, but we're going to go through it the long way to understand the thinking behind it. So the first thing in terms of momentum is that momentum before equals momentum afterwards. So we have the object first of all, so momentum before is equal to the momentum from T1 plus the momentum of T2, and momentum equals mass times velocity. So here the momentum before is equal to the mass of T1 and the velocity of T1 plus the mass of trolley 2 and the velocity of trolley 2. So this is equal to 2 times 4 plus 2 times 0. So the momentum before is equal to 8. And 8 kilograms per meter squared. And it tells us that the collision is an elastic collision. So that means that if the collision is elastic, that means the kinetic energy before equals the kinetic energy afterwards. So in this situation here, we have the kinetic energy before is going to so the kinetic energy before is going to be half mv squared and plus half mv squared, where this is, sorry, let me just redo this bit. There's going to be half m1 v1 squared plus half m2 v2 squared. So in this one here, we're going to have equal to a half times 2 times 4 squared plus a half times 2 times 0. So in here, that is going to equal, half times 2 is 1, so that's going to equal 4 squared, which is 16 joules. So then we need to look at the options that we have here. So momentum. So we don't have any information about afterwards in terms of within the first part of the question, but we do know what the momentum before and therefore we know that the momentum afterwards must equal 8 kilograms meters per second, because the momentum before has to equal the momentum afterwards, and because it's elastic, the kinetic energy afterwards is also equal to 16 joules. So if we look at A, T1 is at rest and T2 moves at 4 meters per second. So it's going to assume that T1 will move at 4 meters per second to the right. So therefore the momentum for this one, the momentum afterwards, is equal to, so this is equal to 0 because it's at rest. So it's going to be 0 times 2 plus 4 times 2, which is equal to 8. So it meets the momentum condition. And then kinetic energy condition is going to be half m0 squared, so half times 2 times 0 plus a half times 2 times 4 squared, which is the same as we just found, so 16 joules. So currently that makes A the answer, but we'll look at the other options that we have. So currently A makes sense, but we'll look at B, C and D. So the next one we have is B. T1 will rebound from T2 at 4 meters per second. So this means that the trolley will go backwards at -4 because it's rebounding, therefore the velocity is changing direction. So, and this remains at 0, assuming it remains at 0. So here the momentum is going to be -4 times 2, which is -8. And this is not equal to the momentum before, so therefore it cannot be correct. And the next one, T1 and T2 will both move at 2.8 meters per second. So in this case, they're both moving at 2.8. So if we do the momentum, it's going to be 2.8 times 2 plus 2.8 times 2. But if we plug this into the calculator, so 2.8 times 2 plus 2.8 times 2 is equal to 11.2, so that's not possible, so because the momentum is not conserved. remember the momentum has to equal 8. And then finally, we've got the opposite, another one which is 1.4. So we'll try this one. So 1.4 times 2 plus 1.4 times 2, which is equal to 5.6, which again does not equal to the momentum of 8. So therefore that one is ruled out. So our answer here is just going to be A. If you have any questions about this question, please let me know.